Hi everyone, hello. All right, I think we are good to go. I hope everyone can hear me on YouTube as well. All right, perfect. Hi, hello Shubham, hello Kavya, hi Aman, hi Shaumya, hi Priyanka, hello everyone. Let's just wait for another 30 seconds more and then I think we can start. Hi Sneh. Don't worry, Aman. I am going to share every information with you about what the course is, what are we doing here, what's the purpose of this class, everything. Hi, Surender. Hi, Shivam. All right. I think we are good to go. We have sufficient number of people watching, right? Let's just quickly start, and then I think more people will join in, right? Before starting with anything, first I will like to introduce myself. My name is Riya Bansal. Currently, I am working as a software engineer at Flipkart. Previously, I have worked at various other companies as well, like Amazon and Coding Blocks, American Express, InterviewBit, and I am really passionate about teaching. I have mentored a lot of students in the past, and the number I think just keeps on increasing as I mentor all of you, right? Just to set the right expectation today, just to explain everyone what exactly is the format for the today's classes. So you would have seen previously we already had a lot of classes, right, on YouTube. You can go to the YouTube channel of for CodeChef and you can see that there are already a lot of classes that have happened, and classes keep on going happening again and again. We have started with kind of a different format today. We have launched micro courses which are free of cost for everyone, right? And how does that micro course is going to work is, we are going to have, let's say, a set of 3 classes. Let's say I am teaching graphs here, so there is a graph micro course which consists of 3 to 4 classes, and that is going to basically be a small micro course on the whole topic on graphs, right? That is going to be a small course where I will try to cover as much as I can in these 3 classes and help you cover as many concepts as I can, right? So that is the whole purpose here. All the sessions are going to be 2 hours long, right? And we will be learning through this way itself. We also have a teaching assistant present in the class who will be helping us throughout the class, and if we have any doubts, he'll help us clarify all those queries at that point, right? Also, we are simultaneously streaming on YouTube and Unacademy. So if anyone wants to switch and maybe probably wants to have a better experience, they can join the Unacademy platform as well. Otherwise, I think it will be good enough if you are on YouTube, right? As a prerequisite for this class, it is expected to know, I would say, the basic data structures and any one language that you're comfortable with, right? Either you should know the basics about C++ or Java, Python, any language will work, right? So there will be a 3 set of classes. In the first class, today we are going to cover the very basics of graphs, right? What exactly is a graph data structure, how exactly you look at graphs, and where exactly are the applications of data structures like graphs, right? In tomorrow's class, we are going to learn more about graph traversals. We are going to solve a lot of problems as well. In tomorrow's class, the problem solving will be of basic to intermediate level, and in the last class, that is I think the third class on micro course on graphs, we're going to solve some advanced level questions, right? So I have made sure to design the curriculum in such a way that each and everyone can take advantage of the content that is supposed to be covered, right? So my job will be to give you as much information as I can, to teach you as much content as I can in a well explained manner. One expectation that I would want from you side is, I think all of you must be having that thumbs up emoji in the chat, which must be thoroughly accessible to all of you. You just have to do one thing. Whenever I am explaining a concept and that particular part is clear to all of you, right, you are comfortable with what I said, right, and the entire thought process and the topic made sense, you're simply going to give a thumbs up in the chat, right? So that will help me to clarify that yes, a certain topic that I taught is clear to all of you, right? All right. So quickly, first we will take a poll here to understand how many of you are new to the platform and how many of you have been attending classes before, right? So I'll just take a quick poll. If this is the first time you're coming to the platform and first time attending a micro course, you're going to put a yes, right? And if you have been to previous classes before or have attended any of the classes before of with me or any other instructor, you're going to put a false, right? Okay, let's just quickly see. All right, I see a fair amount of people are new to the class, right? A fair amount of you are quite new and attending the class for the first time, right? So that is, we'll set that right expectation only and try to cover the concept that we want to cover, right? I'll try to give some good examples throughout the class, right? So if at any point you have any doubt, please feel free to ask them in the chat, right? Okay, perfect. I'll just quickly share my screen. Let me know if the screen is visible to all of you or not, right? Give me a second. Can everyone see? Visible, right? Perfect, great. Okay, without wasting any time, keeping the time constraints in mind, let's just quickly start with the topic that we are supposed to cover, right? All right. I would say please be very attentive of the definitions that I tell you, right? Definitions are going to be extremely important. So make sure whatever definition I tell you, you build your thought process with that in mind, right? Many of you already know what graphs are, but first try to unlearn today what you have already been known and try to learn graphs with a new different perspective today, right? I'll help you build that concept from the very foundation and help you understand it. All right, okay, perfect. All right, so what I would define graphs with is, so graph is yet again another data structure, and that is something going to be a collection of nodes and edges, right? In simple mathematical terms here, collection of some nodes or some edges. When I say nodes, I also mean here it could be vertices as well, right? In mathematical terms, if I have to present it, I simply write G equal to V comma E, and here this entirely is a tuple, correct? It will make sense when I give you examples, so don't worry about that. All right, okay, this is the very basic definition. It is simply a collection of nodes and edges, simply a collection of vertices and edges. No other thing needs to be known here. This is the only definition that we know, correct? So let's say if I draw a graph in this way by simply saying that, let's say this is B, this is the name of the vertex B, right? And let's say this is C, correct? So this is simply going to be graph, and if I have to present in mathematical terms, this is how I would do. So G, now here there are two vertices. There is a vertex B and there is a vertex C. So there are two vertices, B comma C, and there is also an edge. So E is an edge. So the edge is BC, correct? This is how you are going to simply represent graphs in mathematical terms, right? Okay, now you will see here I have not drawn any arrow, right? BC, this is simply a straight line, correct? So these are called bidirectional graph. Bidirectional edges, correct? Why a bidirectional edge? Because you can travel from B to C and you can also travel from C to B, correct? If I would have presented it in this manner, then this is going to be a unidirectional edge. That means you can go from B to C, but you cannot go the other way around, right? So that is one thing that all of us needs to understand here, right? That there are two types of edges, right? There are two types of edges. One edge is going to be a bidirectional edge. Assume it in terms of a road, right? So you have two-way roads where you can go from other direction and come back as well. And we also have one-way roads. So one-way road is you go to one direction but you cannot come back, right? Aman, BC simply means a set. So we have two vertices, right? So that is why I have presented it in an array list or a vector kind of a format, right? Now let's try to take some examples, right? Let's try to take some examples. I think then also it will be clear. Take the example of Facebook, correct? Now you have to tell me what kind of a relationship this is going to be. Let's say Vaibhav and Mamta, all right? So we have Vaibhav and we also have Mamta. Now when they are friends on Facebook, what kind of a relationship this is going to be? Unidirectional or bidirectional? What do you think? Bidirectional, correct? So when you make someone friends on Facebook, that is a bidirectional kind of an edge, because you are friends with someone and someone else is also your friend. Perfect. All right, so this is going to be bidirectional. What do you think is in terms of Instagram? Let's say Vaibhav follows Mamta on Instagram. The concept is that Vaibhav follows Mamta. So that is going to be, yes, that is going to be a unidirectional relationship. Why? Because Vaibhav currently follows Mamta, but the other way around might or might not be true. So that is simply going to be a unidirectional relationship, correct? This is like a real life example of how the whole things works. So we have basically here connections are represented, connections are represented using edges, correct? So there is like a big network, right? This is like a I would say a big example of graphs, right? You are friends with someone, your friend is friends with someone else, right? So this is like a big, I would say, network kind of a scenario, and that is like a very good example of graphs. Different people are going to be nodes or vertices, and your relationship with the other person is going to be defined by an edge, right? So that is like the whole scenario that we are working on, right? Now there is one more concept called weighted and unweighted. Let's quickly take in scenario that as well, of weighted graphs and unweighted graph, correct? So what exactly happens at this is, when I say weighted graph, so all these examples that we took, this example, this example, this example, this example of a graph was a case of unweighted graph. Now what exactly is a weighted graph? Weighted graph basically means assigning attribute to edges in a graph, right? Basically I can say that attribute at some point should be comparable and it should also be quantifiable. Correct? By quantifiable I simply mean that we should be able to compare it or quantify it with a certain quantity or a certain attribute. A good example for this will be A, let's say B, D, C. So this is, let's say, this is like a weight of this particular edge. This is like another weight. This is like another weight. This is like another weight. Correct? So that basically means that you are assigning, I would say, a particular weight to a particular edge. So that could be anything. It could be a simple number. It could be, let's say, a money as well, right? If someone lends money to someone else, so you can basically say that here at this point, I can simply say that A lends money to C and the amount is 400. Correct? This is how we can basically try to quantify few things, and this is how the concept is simply going to work. Correct? So that means assigning some attributes to the edges of the graphs, right? This is what we are going to take concern. We can also say that every graph is actually a weighted graph only. How can I simply say that? That if this is the graph given to us, then simply means that the weight of each edge is 0. Correct? That can also be a case, and in these scenarios also we can say that each graph is actually a weighted graph, right? Can everyone just give me a thumbs up now if this much part is clear? The concept of weighted and unweighted, the concept of unidirectional and bidirectional. Just quickly give a thumbs up. Alright, perfect, very good. Now we'll take some examples and try to make this topic and make this small concept absolutely clear. Right. Now you are going to give me examples for all these scenarios. You have to give me a real life example of a weighted and a undirected graph. You have to give me an example of unweighted directed graph. You have to give me an example of unweighted undirected graph, and you also have to give me an example of weighted directed graph. Now quickly think of the answers for all of these. Try to think of a particular, a particular real example where this whole scenario works perfectly. Think about it. Giving a minute to all of you to think, then we are going to discuss. I would want everyone to participate. That will actually help you to clarify if you are correct or not. You have to basically give examples for all these scenarios. Alright, let's discuss. Let's first discuss the second. Okay, we'll go in random order and then we'll try to understand, right? Okay, so for an undirected, right? For an undirected and for an unweighted and here a directed graph, the example is simply going to be Instagram, right? A person might be following another person, right? A person might be following another person, but the other case is not true, right? I might be following Virat Kohli, but Virat Kohli might necessarily not be following me back. So that is definitely going to be a directional relationship, definitely, but I would say unweighted relationship as well. Let's think of an example for this. I have to think of an example where unweighted, undirected graph kind of a scenario works. We have already discussed that. I think that is going to be Facebook. So the good news here is, if Virat Kohli and I are friends on Facebook, that then we both of us are friends of each other, right? That case is going to be true in this case, right? All right, perfect. Let's move to the next part. I have to give an example of weighted and a directed graph, right? I have to give an example of a weighted and a directed graph. I think in this scenario, we can simply say that it could be splitwise. Correct? That means I might be owing someone money, and that amount could be, let's say, 400, right? And the other person might or might not owe me any money, right? Splitwise, okay, I think many of you have not used Splitwise. Splitwise is basically an app where you keep track of money, of how much money you have to give the other person. If that example does not work, take the examples of routes for an airplane, right? So it might be a case that I have to go from Delhi to Bombay, right? And that distance is simply going to be, that is going to be a directed way, because I'm going from Delhi to Bombay, and that distance is going to be that weight, right? Now from Bombay to, let's say, Kolkata, I am going and I am traveling a simple distance, right? So that is going to be another example. So here I will write that as well, that it is going to be flight routes, right? Okay. The other example of a weighted and an undirected graph is going to be Google Maps. Correct? Where we handle distances, right? But we can say, assuming we only have bidirectional roads. So in the first example, we are assuming to have, let's say, bidirectional roads, and in that case I can simply say that the distance from going from one place to another is a certain amount, so that is simply going to be that weight. Correct? This was just to help you understand the concept, and that is also will be used as an understanding for the concepts that we learn further, right? Now another important thing and one pointer that I will give at this particular point of time is the V and E, correct? That was the vertices and edges here. This is simply I would say the most important part, right? Whenever you are considering graphs, vertices and I would say edges are going to be most important. Why? Because that will help you understand and calculate the time complexities in a lot of scenarios, right? So please make sure you give good importance to the number of vertices and the number of edges in a graph, right? Okay, now let's try to learn something new now. Now let's say I have been given a tree, right? I have been given a tree. So tree is another data structure for those of you who don't know. Let's say this is the tree, right? This is a tree. Now let's say there is a node here A and there is a node here B, right? Now tell me how many paths are there from A to B. How many paths do you think are here from A to B? Socho, think about it. paths. I am telling the number of path from where you can reach from A and go start from A and go to B. That is simply going to be 1, right? Why 1? Because this and this. That is simply going to be one path from where I can reach, from where I can start from A and go to B, right? That was a simple thing, that there is going to exist one path from A to B, right? Now, can it happen that there exists more than one path between two nodes? Acha, tell me, in a case of trees, can it even happen? Can it happen that there exists more than one path between two nodes? Can it even happen in case of a data structure like tree? We are talking about trees here. No, it can never happen, right? It can never happen that in case of a data structure like tree, there can exist more than one path from going from one node to another node, right? Now let's suppose it does, correct? Although it will never, let's suppose it did happen. Let's suppose it did happen. So this is what it will essentially be like. Let's say I had a connection here also, and this was yet again our A, this was our B, and we simply made this connection also, right? And this is what we have made here is a cycle, right? What we have made is a cycle here, right? So what we can simply conclude from here is that tree is a special kind of graph with no cycle. You will see here, the moment I connected it here, it simply had a cycle and we came to a scenario of graphs only. So we can simply say that tree is a special kind of graph with no cycle, right? Tree is simply a special kind of graph and it is never going to have a cycle. So technically tree is going to be a graph only. Perfect, clear to everyone? Just to clarify that tree is going to be this kind of a scenario. And what are simply trees are directed acyclic graphs. अगर सबको clear है, then give a quick thumbs up. This is a very, very important thing that all of us needs to understand. So definitely there is always going to be a direction here for moving in different paths, and that is how we are going to learn it as well. Okay, by directed, if you can say like it is undirected. So when I say a tree kind of a structure, na, see, you always are from parent and you move to child, correct? So this is what I mean. Technically you can say if you are directing a path and you go traversal in the other manner, you can call it in kind of I would say bidirectional. But you see here, when I call a tree, so you always have a relationship where you move from parent to child, right? This is how I am calling it directional, correct? Because we are moving, because we are saying in this case that from parent we are moving to a child. That's how we are trying to represent it. Correct? All right, perfect. Chalo. So what we are simply here going to learn another concept is, that is the concept of clique. So these are very small terms that I am introducing you right now, so that you don't forget it in the future, right? So let's say if I have a graph that looks like this, right? If this is, let's say, a graph, right? And here I can say that from each node, every other node is connected. Here, each node is connected to every other node. And in case of a graph, a particular kind of graph in which each node is connected to every other node, we can simply say that that is going to be a clique, right? That means from each node I can directly go to every other node, right? So I don't have to traverse in any topology. I can simply go to each other node, right? So that is going to be a clique here. Now tell me, let's say there are n nodes. Minimum, how many edges will be there to connect all of them? Not directly, in any way it will work. You have to tell the minimum number of edges to connect them. Lakshay did put it in the right way. All right. Tell me the minimum number of edges that will be required. The answer is going to be simply n minus 1, right? Let's take an example here. Let's say मेरे पास 3 nodes हैं. Let's say 4 ले लेते हैं. This. So the minimum number of edges it will take either is this, right? Or if I want to draw another, then it can be this also, right? So here we can conclude that the minimum number of edges here, the vertices were n, right? Or nodes here was n. The minimum number of edges is going to be n minus 1, and that is exactly like the tree kind of a structure also, right? Okay, now tell me, in case of there are n vertices in graph, what will be the maximum number of edges? What will be the maximum number of edges? Think about it. Take a few examples in your notebook probably. NC2, correct? So the worst case, or I would say the maximum case, would be when I have this kind of a scenario, right? If we want to take an example for that, let's say again I have this case. So the maximum number of edges will come in the case when I have this. So this is directly connected to all of them, right? This is also directly connected to all. This is also directly connected to all, right? So a clique instead is going to be that part, right? In mathematics, NC2 is combination, right? I hope everyone knows that, right? So we have covered the minimum number. This is actually going to form a tree itself only, right? In the maximum case, we are going to have a click, right? If this much part is clear to everyone, just quickly give a thumbs up. Then we'll move and learn a new concept after this. Clear, right? Perfect. RPM, you can definitely ask your doubt if anything is not clear, right? That is like a basic mathematical concept. NC2 is n combinations 2, right? So if you know the concept of permutations and combinations, you should be able to understand that. If not, I would suggest to brush up on that topic once, and then you will be able to understand what I'm trying to teach. Okay, now tell me some views. I'm trying to keep the class interactive so that all of us are actively learning each and every concept. Tell me, I'm just drawing this a box. In this box, do you think this is a graph or not? This whole scenario. Is this a graph or is this not a graph? Think about it. This is the only information that I have given you. Just look at this particular part and tell me if this is a graph or not. Nothing more that has been given to you. So don't make any assumptions. Just try to tell answer on this. All right, I am getting conflicting answers. What about others? अच्छा, मैंने क्या बोला था? Just be focused on the, I would say, definitions. एक बार definition देखते हैं graph की दोबारा. Let's look at the definition. What I simply said was, graph is going to be a collection of vertices and edges. I did not put any constraint here that the edges have to be greater than 0, correct? So the example that I have shown is definitely a graph. If someone asks you, is this a graph? Yes, this is definitely a graph. This is just a disconnected graph, right? This is simply going to be a disconnected graph, right? Like I told you, there is no constraint on that the number of edges have to be greater than 0. I can have literally no edge and still it is going to be a graph. This is going to be a right. Like Deepak said, this is going to be a null graph. This is going to be a disconnected graph, right? No cheating. This was actually the concept that we had to learn. That's why I said focus on the definitions, focus on the very basic concepts. Many a times it will happen that you know something, the concept is there, but you forget the underlying definitions and the concept does not make sense further, right? So what we did learn here was, we learned another concept, that this is, let's say, if I draw another scenario, let's say A, B, C, D, E, F and G, H. This. Here definitely this is going to be a graph, right? This is going to be a undirected graph because definitely there is no direction on the edges. This is going to be a disconnected graph, right? And each part, or I would say this part here, is called a connected component. अब connected component क्या होता है? Let me define first. We will just go by the definitions and learn all the concepts today. Now what exactly is a connected component? It is a subgraph of a graph in which if I choose any two nodes, I can visit them. एक बार फटाफट डेफिनेशन को रीड करो. Read the definition once clearly and the concept of connected component will also make sense. It is what? Simply a subgraph of a graph in which if I choose any two nodes, I can visit them. है ना? I should be able to choose any node and I should be basically able to reach them. अब ये जो पूरा ग्राफ है, ये पूरा ग्राफ कनेक्टेड नहीं है ना? बट ये जो एक कॉम्पोनेंट है एक ग्राफ का, दिस कॉम्पोनेंट ऑफ द ग्राफ इज कनेक्टेड बिकॉज यू कैन रीच फ्रॉम B to A, B to C, B to D. You can also here go from, so you can go here from B to A, you can go B to C, you can go B to D, right? You can also go A to B, A to C, A to D, right? There is a path that exists, that you can follow this direction and reach there. The path may not be direct, but there should exist a path. You can also go C to A, C to B, C to D, and similarly you can go D to C, D to B, and D to A. If in a particular component, if in a particular subgraph I can simply do that, then I can say it is a connected component. Yes, definitely all of you are correct here that E and F is also going to be a connected component. Now tell me, in this graph, what is the total number of connected components? I think that will help you understand the whole concept. I want an answer from everyone on this. Think about it. Arey, the answer is 4, na? This is one connected component. This is second connected component. This is third connected component, and this is fourth connected component. है ना? This is the concept that we have learned. And simply there are going to be 4 connected components in the whole graph. Vaishnavi, G is a connected component in itself. देखो, one particular node, just one particular node can also be a connected component, right? And this is a separate connected component. The constraint is that within a component you should be able to go from one node to another node. Across connected components there is no rule as such, right? See, I think people got confused here a little bit. What I meant was that if I simply choose to go to one in a particular direction, I can, right? It's not the case that in a connected component there should be minimum 2 nodes. ऐसा कुछ नहीं है, right? The concept that I was trying to tell was that in a connected components, we are in a case where we can go from one node to another node. Again, there is no constraint that there should be at least 2 nodes. Right? Does that make sense now to everyone? That it is not the case that minimum 2 nodes would be there, right? My concept was that what I was trying to tell you was that if that is the case, you should be able to go from one node to another node, but not necessarily 2 nodes should be there at least, right? Otherwise the whole concept will not make sense. Correct? Right. Acha, tell me, in this case, is this a connected graph? Now again I am saying please focus on the definitions. If you will not focus on the definitions, you will make mistakes. And give reasons also for saying yes or no. The answer here is simply going to be no. Why no? Let's look at the definition here. Again, like I said, if I choose to go in a connected component or let's say in a connected graph, I can visit each node from every other node. अच्छा यहाँ पे देखते हैं आप. I can go from A to B. I can go from A to C. बताओ, can I go from C to A? Can I go from C to A? I cannot go from C to A. So the answer is going to be no. Can I go from B to A? No, right? So the very concept remains same here, that since you cannot go from one node to another node, each and every path is not possible, the answer is going to be no. Okay, now you must be feeling ki the concept of connected, not connected, the concept of weighted, unweighted, directed, undirected, these concepts actually might look very trivial, but they are going to be extremely important, right? From the interview perspective also, from competitive programming perspectives, these are the small things that you have to take care of, right? Directions play a lot of roles, and I would say a big role in actually the problem solving, right? So that is one thing that we should be learning right now, right? Is this much part clear till what we have discussed? Let's just take a quick recap here also for a minute to everyone. So we discussed introduction to graphs. We took a very basic idea of how graphs are going to work. We discussed the mathematical way we are going to represent it also. We understood what is the concept of unidirectional, bidirectional. We took some examples to support our statements also. Then we understood the concept of weighted and unweighted graphs, right? We are basically assigning a attribute to a particular edge of the graph. In literal terms, we can say that each and every graph is going to be connected. Then we did some small examples and tried to understand that. We also tried to understand a tree is simply going to be a special kind of graph only, right? And also from going from one node to another node, there is simply going to be one path itself. A graph which is, I would say, complete graph, or I would say completely connected, each node to every other node, I would simply say that is going to be a clique, right? I can simply say that if there are n nodes in a graph, there are going to be n minus edges, n minus 1 edges, and that is going to be the minimum value. If I have to find the maximum value is NC2, right? Now we also understood the concept of connected components, a particular, that is simply a subgraph within a graph which is completely connected, right? And by connected, I mean to simply say that I can go from one node to another node. Then we understood some examples and tried to learn it. Is everyone clear with what we have discussed? Just give a quick thumbs up, then we'll move forward. Shri, that is just a constraint. No, Vaishnavi, in connected graph, the path cannot be exactly, I would say, the same, right? If you have to take an example here, so some people are having a doubt that if connected component and if I would say a clique is same. So एक example लेते हैं. Now this is a connected graph, right? Because there is a path from A to C, right? there is a path from A to C, but that path is not direct, correct? You have to go via B. If this would have been the case that you had this node, now we are at the case that we can call it a clique. That is, there a path exists from A to B and A to C, and that path is direct. You don't have to go via. Okay? So that is what the small concept is that all of us needs to learn, right? Now next we are going to cover graph representations. अब हमने graph तो पढ़ लिया, हमने concept भी समझ लिया, we understood how graphs works also, but now we come to the world of programming, and now we have to understand how exactly we are going to represent graphs in a real life scenario, and maybe basically use the memory of the computer to represent it. So there are basically a few ways to do that, although there can be multiple more ways as well. It completely depends on how comfortable you are with each implementation. We are going to discuss a few. So the first is adjacency matrix. Right? Now what exactly is an adjacency matrix is, let's say I take an example of a graph. Now I will represent it in terms of a matrix. So here this graph that is given to us is unweighted, and this is bidirectional, or I would say undirectional graph, because there is no directional, or let's say bidirectionally bolte hain so that nobody get confused. Right? So if I have to represent it in terms of graph, this is how I will do it. So if A is connected to B, so AB, I will put simply a 1 here. Now B is also connected to A, so B is connected to A, so a 1 here also. B is connected to C, so B is connected to C. So in this cell I am going to put a 1. So if the connection is there, then I am going to put a 1, right? And similarly C is connected to B, right? I am only putting direct edges here, only showing the connection of direct edges, and rest there is no path directly from A to A, right? So there is a concept of self loops also. So there is also a case when there is a path from A to A. This is a concept of self loops. So there is no self loop kind of a thing here. So rest all the values are going to be 0. Okay? So this is one way that we can do the representation, right? Here I can simply say that if there are n nodes, total space required to store the graph will be n square, right? Because we are making a matrix out of this, right? And you can also see at this point that in case of a give me a second. In case of a simple and an undirected graph, it is a symmetrical matrix. Dekho, if I place a mirror diagonally at this point, this is going to be a symmetrical matrix. So a point that needs to be learned here is, in a simple directed graph, it is a symmetrical matrix. It's not the case that you cannot store other types of graph here. If the case would have been that I have to store something like that. Let's say this is value is 5, let's say this is value is 6. So that also can be easily done. Instead of 1, I am simply going to put the value. So let's say the connection is of this type, and let's say this is of this type. So now it is not going to be the case of symmetrical graph, right? Because here I have a graph, I have an edge from B to A. So B to A, there is an edge that has a weight 5. Now C to B, now there is a C to B, the value is 6, and rest all the values are going to be 0. Correct? Is this much part clear to everyone of how exactly adjacency matrix will be used? Okay, Shaumya says what exactly is a simple graph? A simple graph basically does not have a self loop, and it does not have multi edges also. When I say multi edges, that means sometimes it is also the case that this is pointing to here, this is pointing to here, this is pointing to here, and let's say this is another D that is pointing here. So we do not have multi edges. So that is a case of a simple graph, right? This is one kind of representation which can be used to represent graphs, right? Matrix is simply, I would say in basic mathematical terms, we are simply drawing a matrix here and representing that kind of a scenario. Okay, let me just repeat this part once again. What exactly is an adjacency matrix? तो हमने यहाँ पे एक simple matrix बना दिया है. हम कैसे represent कर रहे हैं? अब यहाँ पे A B से connected है और B भी A से connected है. तो there is a connection from A to B. So A, B एक इसको edge बना के और एक coordinate बना के हमने किया है. तो A, B का cell कौन सा हुआ? ये. यहाँ पे हमने we did put 1. Right? Now B is also connected to A, so B is connected to A. So the common cell here is going to be this. So wherever I have a edge, I am going to put a 1. If this would have been a weight, जैसे आप यहाँ पे देख रहे हो, यहाँ पे एक weight लगा हुआ है, that means B से A जाने का एक weight है. That means B से A और यहाँ पे हमने एक weight assign कर दिया है. Right? So if there is a weight present, so we can assign the weight also. Otherwise, if there is no weight present, so you can simply put a 1 there. Right? Correct. Shaumya, right. Clear to everyone? The second part with this is going to be that simply we can say here that the other way to represent graphs is going to be using adjacency list. अब ये क्या होता है? What exactly is an adjacency list? What we simply do here is, for each node there is a list of is immediate neighbor. Right? Now let's say the graph looks somewhat like this. Example ले लेते हैं कोई भी random. लेट्स अज्यूम करते हैं वेट्स नहीं है पहले एक बार, ठीक है, उसके बाद वेट्स इंट्रोड्यूस करेंगे वरना इट विल गेट कंफ्यूजिंग. राइट? सो इफ आई हैव टू रिप्रेजेंट इट, सो व्हाट वी आर सिंपली गोइंग टू डू इज, इंस्टेड ऑफ स्टोरिंग दिस, अभी हम क्या कर रहे हैं, हम ये भी इंफॉर्मेशन स्टोर कर रहे हैं कि दैट बी इज कनेक्टेड टू ए एंड सी, है ना. ये पर्टिकुलर रो को देख के वी कैन नो that B is connected to A and C. हमें ये तो पता चल रहा है, but we are also storing the information that with which node it is not connected, right? So that information does not need to be stored, and we can simply store it this way, that 0 is connected with 1, 1 is connected with 0, 2 and 3, and 2 is connected with 1 and 3, and 3 is connected with 1 and 2, right? So this is how we are representing it. You can use, I believe, a hash map kind of a structure here to store this information, where this could act as a key, right? This could act as a key, and you can have multiple values against a key, right? Let's say in form of an array list or anything like that, right? So this is how we are simply going to store all the information, right? So this is a adjacency list kind of information, where we are simply storing with which nodes actually we are directly connected it with, right? So in this case, what do you think is more efficient? List, right? वैसे तो if I tell you effectiveness, तो effectiveness is kind of a relative term. It really depends on what we are comparing it with, right? So if we talk about in terms of space, ठीक है? If we talk about in terms of space, then definitely adjacency list is better, right? If we talk about here now in terms of space, then definitely adjacency list is better. Why? Because we save space here, right? Instead of actually using a space of order of n square, we are saving space here. But can you think of a case in what condition will the space taken by both will be same? एक ऐसा केस बता सकते हो where the space taken by both of them is same? Correct. In case of a clique, or you can also say in case of a dense graph. Let's say we have this, a dense graph कह सकते हैं हम इसको, clique भी कह सकते हैं, right? Dense graph is which has a lot of edges. So in this case, what will happen is the time taken by both, I would say the time taken by both the adjacency list and the adjacency matrix is going to be exactly same, right? So that is going to be the case. Now, can you tell me in a particular scenario, the question simply is for a node I, tell its direct neighbors. Which implementation will you prefer? That the question simply that has been asked is that given a particular node I, tell its direct neighbors. Direct neighbor means the node with which it is directly connected. Correct. List will be better. Right? In any case that you think where adjacency matrix will be better? In any case where you can think of where adjacency matrix will be better? Aditya, in case of a matrix, it will be an order of n traversal, whereas in case of an adjacency list, it is going to be order of 1 traversal, right? Because in key hash map kind of a way, you can simply just get the node and get all these values in order of 1. Whereas in this case, if you have to get the neighbors of B, you will have to traverse the entire row. So it's like an order of 1 and order of n direction. Acha, let me tell you a case, then tell me which one will be better. Now tell me which will be a better implementation. Correct. Very good. In this case, we can simply say that the better implementation is going to be a matrix kind of an implementation, right? And I think the reason itself is also pretty clear. Why? Because if I have to check if two nodes are connected or not, I can just simply go to the graph. Let's say if I have to check if B or C is directly connected or not. So I will go to B, C. This is the node that I know will contain the answer or not. Whereas in this case, if I have to check if 0 and 2 are connected, I will have to traverse the entire matrix of 0 and then try to find the answer. So when we talk about effectiveness, that is definitely, I would say, a case where you have to understand the pros and cons and also try to understand the use case as well. Correct? Does that make sense to everyone? Clear na? Whatever I am trying to convey here, right? So we'll end the theory part here, right? We did a lot of theoretical parts and we did learn a lot of things. Now let's just quickly go to an IDE and try to implement it, right? I just don't want to give the theoretical part. Let's just try to implement it also and see how the whole implementation will work. For our use case right now, we are going to use adjacency list, right? I will write the implementation in Java and we'll be using an adjacency list. You can implement any which way you want. Alright, so we have alright. So I am using an eclipse here. You can use any part you want, right? So for representing a vertex, right? So we have different vertices present, right? So for representing a vertex, I am simply going to use a hash map. So this is what I have written the shortcut for neighbors, right? So this is how we are going to all right. Okay, so for each vertex, we will have a list of its adjacent neighbors, right? So this is how we are going to store that information. And in total also for the whole graph, we should know what all the vertices are. So string will be that value of a particular node and vertex will be that particular vertex only that is directly connected. And this is simply all the vertices. Right? Okay. Now let's see how we are going to implement the rest of the functions, right? So let's say I have to add a vertex, correct? I have to add vertex to the graph and string. So I got the name of the vertex also. So what I will simply do is I will make a new vertex, vtx equal to new vertex, and then I am simply going to add this to the list of vertices. So I will say vertices dot put whatever name that was given to me, right, and the vertex object here as well, right? So this is how we are going to use it. So I am using currently Eclipse here to solve all the doubts. Aman, I am taking doubts from not just Unacademy, from YouTube as well. If there's any doubt at any point, I am like trying to take it up. Actually, there are a lot of students who are texting simultaneously, so the chat is actually moving in a fast mode. So I might have missed few of messages. Alright, so whenever I have to add a vertex, I am simply going to do this, right? Let's just say I have to add a edge also. So there can be a lot of auxiliary functions as well, but let's say this. So I have to do public void add edge. So I will be given two vertices. Let's say this is the name of the first vertex, this is the name of the second vertex, right? And also let's say I have been given a cost of the edge. So I have to connect. So first I will get these two vertex. Vertex 1 is going to be vertices. जो भी सारी vertices हमारे पास हैं, get that name, get that vertices with the name that is given by the user input. Get the second vertex also, which needs to be connected by the edge, right? And then I simply will first check if the vertices are actually even present or not. अगर if any of these cases are true, एक ये भी तो केस हो सकता है ना, let's say that vertex 1 neighbor contains already v2. That means that vertex 1 has a neighbor that is the second, that is the vertex that was supposed to be saying that. Can you tell me that this is actually the case here when the nodes are actually connected? So the case that we are going to check is if one of the nodes are null, or if the nodes are already connected, right? Which I can simply check from this case. What I'll do is I will simply return, right? Otherwise, that means I will simply do this. Vertex 1 के neighbors में I am simply going to put the other node, right, with the cost here, right? And in second vertex neighbors also I am going to put the first node with this cost, correct? This is what you simply have to do. When you have to add a vertex, the concept is actually very simple. When you have to add the edges also, this is going to be that. Let's put it in the center. All right. Let's just add a few more auxiliary functions also. Neeraj, you can use any implementation you want, right? Like I said in the start only, I am using hash maps here to solve this problem. You can use any which data structure you prefer, right? There can be multiple ways to implement a graph, and you can use any way that is preferable for you. All right. Let's say I have to check the number of vertex in the graph, right? Let's just write a few auxiliary functions as well. Public int num vertex, then I will simply just return vertices dot size, right? So this is what I am simply going to return. Let's write a function for how we are going to display the whole graph as well, right? We have to display the whole graph also, right? So we'll write one more function, then I will show you a few examples if this code works or not. So I have, let's say, public void display. So what I will do is, let's say, so if I have to display, so first I will get the value of all the keys. So this will give me all the keys. Now for each of the key, I am going to print right. So for each vertex I will get all its neighbors, right? And when I say vertices dot get key, so first I am just getting that vertex only, and simply I will print key plus, just for the visual format I am doing this, right? So I'm going to take its neighbor and then simply print the string. Then I'm going to put it again here. Now let's make another client class, otherwise this code will become extremely long. All right, so we have graph. I am making a object of the graph class that we had. So let's say in the graph I had to add a few vertex. So let's say this is A, B, C, D, E, F, G, right? So these are the vertices. Then I am, let's say, adding the edge also. This is A. Let's say I am connecting it with B and add the cost one. Let's say I connect A and D with the cost 10. I connect B and C with the cost 2. Let's say I connect C and D with the cost 3. I'm just giving a big graph example here so that we can verify what we are doing. So let's say D, I'm just taking any random values. Let's say D and E is connected. D is, let's say, any cost that you can take here is 4, and let's say E and F are connected. E and F is connected by, let's say, 5. Let's say I have E to G. E to G is 12, and let's say I have F to G. Let's say this is 4. All right, let's quickly try to display the graph now. So we'll do graph dot display. Now let's see if that works or not. right? So I have A, it is connected to B with the cost 1, which is correct. Connected to D also with the cost 10, that is also correct. Let's take the example of E as well. E is connected to F and G, and is E connected to D as well? No, E is not connected to D plus D, but D is connected to E, and we are taking a bi-directional kind of a relationship, correct? So if D is connected to E, E is also connected to D. We saw that in the example also because we add both the cases. So here this connection is also worked out. So here we have taken an example of a bi-directional kind of a relationship. You can represent any relationship you want. Clear to everyone? Any doubts? It's okay. If there's any doubts, you can definitely ask. Have a look here. Have a look at the code once. If there's any doubt, you can definitely ask. I actually did not see any doubt. Did anyone had a question? Yes, they are different. एक बार देख लो implementation. Whatever I did try to tell here, for a particular vertex, we are simply trying to keep the information with what other nodes that is connected and also with what cost. Here I am maintaining all the vertices, and this is the function for adding an edge, and this is the function for adding a vertex to the graph, and then we also had a function for displaying the whole I would say graph, right? If this much is clear with what I have told, just quickly give a thumbs up in the chat and then we will continue. Amarnath, I'm not sure exactly what will be the exact implementation for C++ because I don't use that. But as far as I know, in C++, you are going to use vector of vector and then try to solve this problem, right? If you have to implement adjacency list in terms of C++, then you can use vectors of vectors and then try to solve it. And I think hash maps also exist in C++ as well, right? So you can use hash maps also and that will also work. Manu, this session is ideally supposed to be 2 hours long. Right? All right. Yes, I can display the code. Have a look. You can write more functions, right? This is not the only implementations that you have to look for here. They can also be a function, let's say, where you have to remove an edge, right? So what you can do is after the class, you can try to work on those concepts also, that how exactly you will implement a function where you have to remove an edge. Let's say you have to implement this function. I will give you string name 1, that is the name of one edge, and I will also give you the second edge. Can all of you write the function where you simply have to remove an edge? Right, Siva, that is adjacency list. Right? So try doing that, right? Try doing that. Let's say you have to implement a function where you have to remove an edge, right? So that exactly how you are going to do this. This is also something that you should try to do on your own, right? Okay, let's move forward. We still had half an hour. we'll talk about graph traversals a little bit, right? I'm not sure if we will be able to complete it, but let's try to cover as much as we can, and the rest part we'll cover in the next class. All right, so we'll start with that topic today itself. All right, perfect. I hope everyone is with me so far. Right. अब क्या होता है, we will talk about graph traversals. So when we talk about trees, right, when we talk about trees data structure, we have trees traversals. Like we know that like tree has tree traversal, graph has graph traversal, right? Let's say agar I have been given a graph like this, there are different kinds of traversal, like we have in order traversal, post order traversal, pre-order traversals, right? These are different ways. Traversal could be that these are different ways in which I have to go to each and every node, each and every other node of the graph, right? So let's say I'm simply following this. So I'm going to 0 to 1, then I'm going to 1 to 3, then I'm going back, then I'm going 1 to 4, then 0 to 2 and 2 to 5, right? So in case of a tree, it is easy. अब क्या होता है ना, like I told you, the concept was that trees do not have cycles. So in case of trees, graph traversal is easy. So in case of trees, traversal is very easy. But एक ऐसा case consider करो where you have to follow the same concept, but in case of a graph, so this is, let's say, the graph, right? Very similar to the previous one, just one node that I have. So here you go from 1 to 2, right? So let's say you are currently at 0, you go to 1 and you go to 2, right? Now and again, अब यहाँ पे क्या हो सकता है, you can go again from 2 to 1 and then again you can go from 1 to 2, correct? So what can happen is you can actually go into a case of infinite loop. In trees we do not have cycles, so we do not come across this problem. But here what can happen is, let's say from 0 you go to 1, then you go to 2, then you come back to 1, then you go back to 2, correct? Because we have I would say here a cycle. So traversals in case of a graph is going to be very traversals in case of trees is going to be very easy, but in graphs we have to take care of a few things, right? And how do we prevent this case? How do we prevent this case of infinite loop? We keep a visited array. ठीक है, अब हम क्या करेंगे, हम एक विजिटेड एरे रखेंगे जिसमें वी विल कीप ट्रैक ऑफ द फैक्ट कि हमने कोई नोड ऑलरेडी ट्रेवर्स कर ली है या नहीं करी है. Simply meaning that we are keeping an array which will basically keep track of all those nodes which have already been traversed or not. So if there is any node that I have already traversed, I will simply put it as a part of the visited array, right? So in order to solve this problem of visited list, we are simply going to use a visited array, right? Now here also in terms of graphs, here we have two approaches, right? The first approach is going to be DFS or depth first traversal. The name here itself should be very intriguing and understandable, that we are giving preference to depth first and we are going to give priority to depth and traverse it first. Let's take an example. Here let's say you have this kind of a structure. Right, and you can start the traversal from anywhere. Acha, one more example or one more difference what I would say in terms of graph traversal and a difference from, I would say, tree traversal is, in trees traversal always start from the root, है ना? In trees the traversal always start from the root node, but here since we do not have the concept of roots, we can say that in graphs the traversal can start from literally any node, right? So you can start traversing the whole graph from any which node that you want. So I am writing that here also for all of us. So you can start graph traversal from any node, right? What is simply going to happen is, let's say I am going to start from 0 here, right? Now let's say I draw one more connection here also. Let's say I have this connection also. So let's say this is the whole graph that is given to you and I simply start from here. So what will happen is, first if you are at 0, let's say you have two options. So from 0 you can either go to 1 or you can go to 4, right? Because these are the direct neighbors here that I can go for. So you can choose any neighbor. Let's say I choose this neighbor, right? Now what will happen is, from 4 I also have two options again. So let's say I choose this neighbor and I am also maintaining a visited array. So I have visited 0, I have visited 4, right? Now for this particular node 4, I have traversed the entire depth at a particular side, right? There is no way forward I can move here. So what I will do is, now I will go to the other node, that is going to be, I would say, 6. Now you will see here that on one side, right, from 0 I had two options. On one side for 4, the entire depth that was present has been traversed. Now once you have gone through the entire depth, now you will start with the other node. Okay, you pick a particular neighbor, you go to the entire depth of that neighbor and then you come back. So here also actually the entire depth was not done. If you will see here, for 4 one part was left that you could have gone to 1. So after doing 5, after doing 6, you can go to 1, right? From 1 you can go to 2, then you can go to 3, and then you will come back. You will see that from 0 to 4 all parts are done, then you will move to the other side. Now here you're not going to do the same part again and again because one had already been traversed. So I'll quickly show you what is the order of elements that we traversed. So we had 0, then we had 4, then we had 5, then we had 6. So 0, 4, then all its neighbors, 4, then 5, 6, and then gone to 1, then 2, then 3. Clear of how exactly the depth first traversal is working here? I hope that is clear to each and every one of you. If we have to write a pseudo code for this, right, एक छोटा सा pseudo code लिखते हैं, then in the next class I want all of you to give an attempt once of how exactly the implementation will work. You will try to write it once and then we'll discuss in the next class. So let's say this is the main function that we have. So here, if we are starting from the 0th node, so in the visited array I will mark it true, right? Let's say the visited array has true and false values, right? And we are going to call the DFS and start it with the 0th node, right? Let's say I call the DFS function here. So void DFS, let's say this is the node, right? Also, like I said, I am maintaining a boolean array also. So let's say this was the bool is visited array and it has information about all. So true or false values will be stored here. And here what is simply happening is, whatever node you come across, you simply print it. So we print that node and then we go to all its neighbors. So for all j in the adjacency list of the given node, right? What I am simply going to do is if, acha batao, what would be the step here first? I printed that current node, right? In the first step I printed that current node, then I went to all its neighbors. What should be the third step here when I go to each neighbor? Aditya, should I do anything before that? Acha dekho, let's say currently I am at node 0. Now when I go to 0 neighbors, first I should check if that neighbor is already visited or not. Otherwise I will come again in the case of infinite loop. So first I should check if that neighbor is already visited or not. If that neighbor is not already visited, right? If that neighbor is not already visited, then you simply first put a true on that neighbor, because now you are visiting it, and then you recursively call DFS for that neighbor. This is what we will do, and this was actually the entire implementation also. Clear to everyone of how exactly depth first traversal is going to work? We are first going to check the entire depth, and once we have completed the entire depth, then we move on to the other part, right? If for just for clarity purpose, let's do it together, right? Let's say I start a DFS traversal from any random node, right? I start DFS traversal from any random node. Let's say it is A, right? Now let's say I go from A to B. Now tell me what should be the next path here? What will be the order of traversals? A, B, then next node is going to be? You can either go to D or you can go to E. So let's say A, then we went to B, then we went to E, let's suppose. So this is what we have done, A, B, E, right? And then let's say we are again choosing a direction. Let's say I chosen F. So you will see here I am just going to the depth first. So let's say I chose the depth F, right? Then what can simply happen at this particular point of time is, let's say this was directed also. यहाँ पे ना directions भी बना देते हैं. Right? Now you will see here that after we have come to F, there is no more depth that I can go forward, right? There is no more depth then I can go forward. Then I will simply come back, and then I will go to another depth, that is D. So that means now I am traversing D, right? Then after D, will you go to F again? Will you go to F again here? No, right? Because F has already been traversed. Then you simply come back and then you traverse this node. That is the other branch it is going to be, and this is going to be C, and then you simply, are you going to go from C to E? No, right? Because it has been already visited. So that is simply the order of the elements that is present, and I have also written the pseudo code as well, right? Not today we are not going to write the implementation, right? Today we are not going to write the implementation. The implementation will be done in the next class. Shiva, yes, you can choose that. That is perfectly your choice, right? If you have two options to go in a particular direction, you can definitely choose any direction. Hamza, the advanced class will be on the third class. So today is a beginner's class, second class is going to be an intermediate session, and the third class is going to be an advanced session. Right? And let's also see an application. Let's say the question that is given is, so I am discussing small problems also simultaneously so that we don't miss anything. Let's say the question is, given an undirected graph, you have to tell whether it is a connected graph or not. बताओ कैसे करोगे problem solve? How will you solve this problem? Let's say this is the graph that has been given to you, and you have to tell whether the graph is connected or not. How will you solve this problem? Think about a minute, right? Take 2-3 minutes, think about the solution for this problem, and then we will discuss. सोचो, what should we mark? अच्छा, Tripti, सोचो, will it be a case if the graph is, let's say, either connected or not connected? Every node will have true. I can call multiple DFS also. Then also every node will have a true value in the visited array. Or if you are just calling it once, then you can probably do this and check, right? If you're just going to call DFS1, then I think that will work. Very good. I think people are getting the right answers here. Think about it. Take a minute more to see. Then I will discuss the solution. The idea is actually very simple. And this is actually a very popular question also. Nikita, connected and weight are not going to be related, I would say. So this whole graph that I showed you is actually not connected, right? Because you can see here that there is no way that I can go from 2 to 5. We do have certainly some connected component, right? There is one connected component, the second connected component, there is another connected component, but the whole graph in itself is not connected. Yes, Manu, but like how are you going to check this condition? I think the solution is actually very simple, right? I'll just show it to you step by step as well. I'll just write down the steps, and I think after that all of you will be able to understand it also. What I'm simply going to do is, first step will be pick any random node, right? And I'm simply going to trigger, or I'm simply, let's say, going to call DFS from there. The third step will be, I am simply going to check the is visited array, right? If any node is false, then the graph is not connected, है ना? Concept बहुत simple है, and the concept is very easy also. That what you can do is, I already have a visited array. इसमें 0 1 2 3 4 5 6 7 8 9 है. What I can do is, let's say I can call DFS from anywhere. Let's say I start calling it from here. Now I have visited 1, so there is a true here. I visited 0, so there is a true here. Now I visited 2, there is a true here. And I visited 3, there is a true here as well. Now you will see here, right, now you will see here that once after calling the DFS once, you will see that there are nodes which have no value, or let's say called a false value. That means they were not directly connected and I could not visit them using the DFS traversal. That means this graph is not going to be a connected graph. Clear to everyone? Quickly give a thumbs up if this whole concept makes sense. Does that make sense absolutely to everyone? Very good. अच्छा, एक follow-up question है, right? A follow-up question that I would ask all of you is, if you have to tell and if you have to implement how many connected components are there, can you do that? How can you implement this? Should be easy. थोड़ा सा tricky लग सकता है, but it is easy. How can you do that? मतलब I know the answer is going to be 3, but how can you implement this solution? Three तो पता है आंसर. I know what the answer is, but how are you going to implement it? With what simple, I would say, way I can say how many connected components are there? अच्छा, ऐसे सोचो, can I not just say this? If I have to basically traverse all the nodes, I will have to trigger DFS 3 times, है ना? ऐसे सोचो, if I have to traverse actually all the nodes of this graph, I will have to call DFS 3 times. Once I will have to, let's say, call on this component, once I will have to call on this component, and then on this component. So can I not just say this, that the number of times I called DFS to actually traverse the whole graph is actually equal to the number of connected components? Can I not just simply say that the number of times that I had to call DFS, right? I'll just simply write it also. Number of times DFS calls took place to traverse the entire graph is going to be equal to the total number of connected components in graph. Quickly give a thumbs up if this part makes sense to all of you. I want to see for how many of you this part is clear. Then I will explain for the rest if it does not make sense. Although the concept is simple, but I'll explain it again if this part does not make sense. Clear? Right, so the number of times we called DFS is 3. So actually the total number of connected components is this going to be 3. And if from one traversal, from one DFS, I cannot traverse the whole graph, that means the graph is not connected and you just, I would say, traversed one subgraph of the whole graph, right? And that is what all we should be learning today. Did everyone had fun learning graphs today? Were you able to, at least clear out your foundational knowledge about graphs? Right? So that is exactly what the purpose is as well, right? That is exactly the purpose also. I would say the first class that we had today was basically to just clarify your concepts, right? Just clarify the very basic things that we need to know about graphs, right? Now with this knowledge clear, tomorrow we are going to basically implement the graph traversals, what kind of different traversals that we have. So we discussed DFS traversals today. I would want you to give an attempt and write the implementation yourself once for depth first traversal. Tomorrow, although I am going to write it, not tomorrow, I think the class is going to be on Friday, right? So next class that we have is Friday 9 p.m. So there I am going to write the implementation for both depth first traversal and another traversal, that is breadth first traversal, right? And then we are going to solve problems and see some more applications of graph, right? So we have many problems like shortest path. So we have many algorithms like shortest path algorithms. We have Kruskal's algorithms and we had Dijkstra's, many algorithms, right? I don't think I'll be able to cover all, right? I'll not be able to cover all of them, but I'll definitely try to take up a few of them and help you clarify the concepts, right? Alright, perfect. I hope everyone is clear, right? I hope everyone had a good session as well. The teaching, I think we had a good session where we were able to clarify a lot of concepts also at each particular point of time, right? Aman also, thanks to Aman also for the class today. He was able to help us throughout the class. He was trying to take queries on both the platforms, right? We'll try to keep these sessions up and pacing as well throughout the rest of the classes also, and we'll try to learn this in a similar format as well, right? Thank you everyone for attending the class. Please stay safe, keep practicing, keep coding. The only way to learn is to do more and more questions, right? And that is the only way that you're going to learn all these concepts, right? So please make sure you do learn, you do practice a lot until we meet next time on Friday, right? Thank you everyone. Bye bye. Good night.